Hari Om friends, and welcome to the third part of the series on the Vijayanagara Empire. So you can see this time I've got a haircut. So I'm unfortunate to get random barbers every time. So there's no uniformity in my haircuts. But this time I'll take a little bit of detour and I'll show you something interesting. But I want you to have patience and watch till the end of the video, okay? Because it will get a little bit boring. But I've tried not to make this video long, so at least try to compensate for that thing. Speleothems, that's the correct pronunciation. So you might be wondering, what is this guy doing? He started the series on Vijayanagara Empire. Now he's, giving us a lecture on geology or geography or paleoclimatology or whatever it is. And he goes off on all these weird tangents, which have no bearing on the topic. But like I said, be patient. And there's a little bit of scientific explanation. So even my knowledge is quite shallow. But I'll try and be as precise as I can. So let's take a look at some natural phenomenon because before we, kind of dive back into Vijayanagara, Alauddin Khilji, and so on. So the image you got in front of you is from an underground cave. Now, if you have visited some of the underground caves, say in India or in other parts of the world, so Araku in Andhra Pradesh has got very beautiful underground caves which have got these natural formations, and the generic name for all these formations is speleothems. But there are different types, there are different varieties. So the ones in the image, for example, which you see hanging from the ceiling, okay, they are called stalactites. And then you got the thinner versions of them, they are called straws. Then you got something called drapers, which is, and obviously the reason is it almost looks like a wind, the curtains, the drapes on the curtains. Then you got the ones rising from the ground, which you got stalagmites. So stalagmites are of interest to us. You got the long ones which reach up to the ceiling called columns, and then you got these kind of boulder-like constructions called flowstones. So the generic name for this entire uh, kind of natural formations is called speleotherms. So speleotherms are basically, what happens is as water percolates down, into the underground caverns or underground caves, it takes minerals with it, especially calcium. Um, and there's a reaction I'll show you on the other page where calcium carbonate is converted into calcium. And this results in deposits forming either on the ceilings of the cave, the stalactites, the straws, and the drapers, or you got these formations which form on the floor of the cave and they look as if they are rising up from the floor towards the ceiling, and these are the stalagmites, columns, and flow stones. And oh, just bear with me a minute. And what happens over time is, when these things start forming, obviously calcium is white, but over time, because of dust and erosion, it gets this dirty brown color. So how is this important to us? Now, the importance is that there's a class of scientists called paleoclimatologists whose work is really to kind of look at past geological records, so like rock formations, especially the speleothems, and then try and understand what was the climate like, say 400,000 years before present, or 300,000 years before present, or 1500 or 2000 years before present. And they study this by two ways. One is called a uranium analysis. Again, I know what it is. I'm not exactly aware what happens in that, but I think they use instruments like mass spectrometers and so on. The second one is, now these natural formations, speleothems, have got oxygen content in them. So there are two different types of oxygen isotopes. One is oxygen 18 and one is oxygen 16. They look at the proportion of these isotopes, and using these, they can actually reasonably predict what was the amount of rainfall, say around 2000 years back or 1000 years back or 10,000 years back. So was there a drought or was there excess rainfall? So this is something that you can predict. Now I'll show you on the next slide, just quick overview at how the whole process of formation of these speleothems works. Okay, so let's hop on to the next slide. Okay, so this is a diagram. Again, I've got these from different papers. So I've indicated the papers at the bottom. If you freeze the screen, you can have a look at them. Uh, Most of these will be available to read for free on sites like ResearchGate. It's usually the preprint version, which is out of copyright. Okay, so let's have a look at this. So these are your underground caves. Okay, and you got rainfall. So water comes in the form of rainfall, or there can be some underground moisture as well. So what happens is, as the water starts to percolate down, now there is carbon dioxide release from the microbes in the soil and from the roots of the trees. So these two things react and they produce H2CO3, which is carbonic acid. So as this carbonic acid filters down into the rock bed, so this is a rock bed, it reacts with the calcium carbonate in the rock bed to form uh, calcium and bicarbonate. So HCO3 is the bicarbonate. And remember, it's still in a liquefied form. So as it starts dripping down, you get these formation of stalactites on the roof or the drapes or the straws. And once it starts pooling on the ground, you get these structures rising up, which are your stalagmites. Okay, and there's something called CO2 degassing, which happens once it kind of hits the cave, where the calcium and the bicarbonate combine again to form calcium carbonate, and the water and the carbon dioxide is released. So that is why you get these reformation of calcium carbonate, so that you get these hard structures. Okay, so that's kind of the basic chemistry behind this. Um and let's have a look at a cross section of a stalagmite. So this is a cross section, and what typically they do is they will drill at different points where you see these lines. These are actually the different layers. And if you analyze the different layers which have been formed over thousands and thousands of years, you can get an idea of what was the amount of rainfall or precipitation that happened at a particular time. So they will drill holes at different places. They will take samples and then they will analyze either for the oxygen isotope or they will do the uranium analysis. Okay. And what happens in oxygen isotope dating, because that's of interest to us, because the study we'll be looking at in the next couple of slides actually uses the oxygen isotope dating, and these reflect changes in the amount of precipitation, how much rainfall, because if there's more rainfall there'll be more deposition, the layers will be thicker, and if there's less rainfall, the layers get thinner because the amount of precipitation or water coming down through the caves obviously becomes less. And this provides a good evidence of the annual rainfall for a particular year or for a particular decade or for a century. Okay, so let's have a look at the next slide. And these are the caves of interest. So in Chhattisgarh, so that's the state of Chhattisgarh. There's a national park which has got a series of caves called the Kotumsar Cave Network, and these have got different caves. I think Dandaka Caves is the most famous, and then there's I think couple of few other caves as well. And see, I mentioned Araku Valley, which is actually in Andhra Pradesh, quite near to Vishakhapatnam. And Araku Valley, it's a very beautiful place. It's known for coffee, well known for coffee forests. There's a fantastic railway line which passes through the mountains. And Araku Valley has got natural caves. So I visited these caves around 2011. And they are very similar caves to the Dandaka caves. But this study was conducted around the Kotumsar cave region, particularly around the Dandak cave area. Okay, so let's have a look at the uh, rainfall pattern, how it works. So this is a image I got from the most recent meteorological website, and that's mosam.imd.gov.in, and this shows how the monsoon kind of proceeds. So the blue lines are when the monsoon actually hit in 2023, and the red lines are when it's usually normally supposed to hit. So you can see it moves from this direction, from the south direction, southeast direction, and it moves up and up. Now, the Dandak caves are quite significant because they are located somewhere here. And looking at this figure from the study, this is the location of Dandak caves, which is where the Chhattisgarh, which it's in the Kotumsar cave network. And the analysis of the stalagmites from this particular region, it reflects the amount of rainfall in a vast swath of India. So right from eastern India, so you got Odisha, Bengal, and right going up to northern, western, and pretty much a large part of central India and the Deccan. So this sample will give you an idea of what the precipitation is. And what I would encourage you to do is go and have a look at this paper by Sinha and a lot of other authors. It's quite an old paper, but a fantastic paper. It's called a 900-year record of the Indian summer monsoon from the core monsoon zone of India. It's available for free. I'll put the link to the ResearchGate site where you can get the paper. Now, I downloaded this paper around 2010 or 11. It's been lying on my hard disk for roughly more than a decade now, which is why I had to read the paper again because I was going to use this to write the historical forward for Madhura Vijayam, but that's never happened, and I'm not sure if it's ever going to happen. So let's move on and come to the core part, the most interesting aspect of the study, which is relevant to us. Because by this point, you'll be thinking, okay, I've got some unnecessary facts on geology, some strange things called speleotherms, and the monsoon patterns. Where is this guy going? So now your patience is about to be rewarded. So here we go. So this graph or this chart is from the same study, and I given the link here. Now, this is very important because if you look at this, this is the year 600 CE or 600 of the Common Era, and their data goes up to I think around 1600 around here. And these stars, what you see here, which are in between these, pinkish, brownish kind of lines. My color sense is not very good, so it might be a little bit different. These indicate periods of drought. Okay, and the stars actually indicate a period of famine. So you can see somewhere around 650 CE there was a series of droughts and possibly a big famine. Same thing if you go around the late 1860s on to uh, the late mid 950s, you get a series of famines and there's very poor rainfall. Okay, and again if you go on to 1020s, now just remember these dates. So this is roughly 10, 20, 20, 30, same famines, and this is more for central northwestern India. Again between 1100 1200 you've got not so much of the dry period, but you've got a series of famines, which indicates there must be some droughts or something. And then as we come to the 1500s, the dry period and the droughts get more prolonged, and you can see these big stars. So these two big stars are the period between 1380s and 1400. There was a massive famine called the Durga Devi famine, and this was comparable to the famines in British India. I think millions and millions perished in those famines. And you got till 1500s. Now, if you think about it carefully, these periods are the periods when the Islamic armies or the Muslims scored major victories over Hindus, and they were able to expand. So if you look at 1300s, this was the period when Alauddin Khilji was able to expand the Delhi Sultanate considerably. Obviously, it shrank back pretty quickly as soon as he died because they never had a firm grip on the whole of India. So they used to capture the cities, but the countryside was out of their control. So as soon as the main army retreated, the Hindu Kshatriyas and warriors used to recapture the cities as well. And all of these kind of links up with two things, because see, imagine if a country, even today India is facing a major drought with a famine, so all the resources are really uh, kind of concentrated around trying to save the people, trying to elevate or lessen their misery. Okay. Now, Islamic armies and the British, they are the same. So you think about, bandits, not in hundreds or thousands, but in hundreds of thousands. Okay. For them, they don't have to feed their people. They don't have to take care of anything. All they need to do is they need to not rob and loot. That's all they need to do. Whereas a normal kingdom or a normal nation state like what we have today has to take care of its people, take care of its economy, take care of a lot of different things. And the military aspect is just one component. The military aspect is not the whole component. For Islamic and the British, the military aspect is the whole and sole component. So it explains why it was not like they had military supremacy. Otherwise, people don't sit on horses and just ride you down. That doesn't happen in reality. It's very complicated, and which was why I wanted to show you this graph, because history is not just about dates and somebody killed somebody else and somebody burnt a city and did this, did that. It's actually a lot of different events, so natural, man-made, economic, cultural, social, which come together and then form a situation which dictates what happens next. So losing or winning on the battlefield is only literally the last part of that whole process. It's not the whole process. But if we read history as it's, or itihasa is the more proper word, as it's taught in India, it's more like that battle is the central point and then everything happens after the battle. The battle is actually the last point. Just a couple of more points. So this chart, just out of interest, is the oxygen isotope level, and you can see there's a certain these dashed lines actually show the kind of average or mean where it's usually in, and when the oxygen isotope level falls very dramatically, it means that rains almost certainly failed, because the oxygen isotope level and the amount of rainfall is inversely proportional. Okay, so if there's uh, one thing goes up and the other thing goes down, that kind of thing. And this is known as the medieval warm period, the period from roughly 900 to 1400. Then you had something called the little ice age. But this is what I really wanted to kind of show you just a little bit, so we can think outside the box, so we are not kind of constrained like a horse. Marathi मध्ये सांगतात ना, डोळ्यावरती पट्टे आहेत. So in Marathi we are saying ki the horse has got these blinds on its eyes and it can only go front. So we don't want to be like that. We want to have different views of how things work. Okay, so that's it for this time. I hope it wasn't very boring. And I would like to acknowledge the sources from where I stumbled upon this information. So the first was a blog post by an anonymous author who goes by the pseudonym of Manasa Taramgini. And the blog is of the same name. I'll put a link to the blog post because I managed to locate it after many years. So he or she, now we don't know if it's a male or a female or somebody else, had published a post around 13 years back where they had given a link to this particular paper and their own analysis, which is very good. And I would recommend that you go and read the whole article. And they had drawn the link between, the upsurge in Muslim military activity and the freak weather, droughts and famines. So I put the link in the description box. The second is an anonymous poster on a forum, which I used to frequent many years back, but I've stopped for almost close to 11 years, who used the pseudonym of Brihaspati. And he was kind enough to provide me a lot of other relevant links to this research. Now, as I mentioned, these papers have been lying on my hard drive for a very long time. So again, I'm pretty much out of touch. So I might have been wrong on some points. So I had to do a little bit of revision before making the video. Anyway, I hope this was a little bit entertaining, maybe boring as well. And I'll see you in the next video. So do take care. And if you like, please remember to share, subscribe, and press the like button. Thank you. Bye bye.